Hello, and welcome back to the Transform Wellness Podcast. This is going to be a longer one because I really wanted to delve in how our body makes energy in our little power plants called the mitochondria. So, mitochondria are these tiny little structures inside almost every cell. They have actually initially thought to evolve from free living bacteria that in evolution got added into our body for a long time ago. And their job is to make ATP, which is our body's energy currency. We need to make ATP. So think of them as your cell's battery chargers. Where are they found? Mitochondria are concentrated wherever the body needs the most energy. So brain uses 20% of total body energy. So lots of energy up here. Your heart, because it's beating nonstop. Kidneys, liver, your skeletal muscle, especially slow twitch muscles. And egg cells, or the oocytes in women, have the most mitochondria of any human cell. And then you want to think of any cells with low energy demands, like your skin, your fat. They just have less mitochondria. So how is energy burned? So you can have, step one is glucose, which is a quick burn, or fat, which is our sustained fuel, enters the cell. Step two, it goes through multiple energy pathways, and step three ends with ATP production in the mitochondria. But let's start with glucose. When we have glucose, first you need to bring it into the cell. That is called the GLUT4 transporter. This is insulin-sensitive glucose door. So this is in our muscle and fat cells. But this is what gets affected with insulin resistance. So when this receptor is down regulated, there's not as much there, that's when we have issues with making energy. So you can't bring in enough glucose, and our body shifts to a slower, less efficient model to making glucose. And that's your GLUT1 transporter, which is our backup transporter. It's always open but slower. But that interesting is the primary transporter in the brain, because the brain needs energy all the time. We don't want to wait till insulin's around. So the initial step is glucose gets brought in. Now in the cell called the cytoplasm, a process called glycolysis occurs. So one glucose makes 4 ATP, but it's only 2 net ATP, which then gets brought into the mitochondria. This step, you need vitamin B1, lipoic acid, coenzyme A, B2, and B3. And then it's going to go down 3 pathways: aerobic or cellular respiration, anaerobic glycolysis, and aerobic glycolysis. I know a lot of people are probably saying, I don't want to remember a biology class in high school. I want to be very specific so you understand why, when you're having issues, why you have less energy. So that's why I'm being very specific. So then it goes to that citric acid cycle, also as the Krebs cycle. So you need, again, vitamin B1, B2, B3. So if you have micronutrient deficiencies, you're going to make less energy. You need B5 as well. You need magnesium. One of my previous talks, I mentioned 80% of people are low in magnesium. You also need iron. So then it goes something called oxidative phosphorylation via your electron transport chain. Then you're making 28 to 32 ATP. So if you're looking overall, that one glucose has made 34 ATP. So this is when our cells are working well. And in that electron transport chain, there's many steps. So you can see can be breakdowns, especially with micronutrients, leading to issues and insulin resistance, which we'll get to. Then when we get to the electron transport chain, you need NAD. So a lot of people take NAD precursors, IV NAD, things like that. You need iron, you need B6, B2, coenzyme Q10. As far as coenzyme Q10, there are drugs that deplete it, like statins. So you got to think coenzyme Q10 there. Copper and iron and magnesium is also important. Now, interesting for those of you that have heard of methylene blue. Methylene blue, you think of it as a jumper cable. It bypasses steps 1 and 2 and gets to 3. So if there's some kind of a block at complex 1 and complex 2, that's where methylene blue comes in. Caveat with methylene blue, do not take it with antidepressants. So aerobic glycolysis is when your cell chooses glycolysis, which is breaking down glucose, even when oxygen is available. So this makes lactic acid instead of running the mitochondria. So this is fast but very inefficient. So you only 2 ATP. So this is what happens when you have metabolic dysfunction, mitochondrial dysfunction, insulin resistance. We start to do aerobic glycolysis instead, so you're making less energy. That's why when people are under stress, lots of inflammation, they feel tired and brain foggy because our body is not using the energy appropriately. When we look at fat, so we do want to burn that on just at rest. So you have free fatty acids or free fats in the bloodstream. They're bound to albumin because fat and water don't mix. It's brought into the cell via a transporter. It can, if it's really small, it can pass a diffusion, but the larger ones, which is most of the fats we talk about, have to be transported. And then fatty acids are activated using 2 ATP, so you're using some energy. And then if they're larger, you need something called the carnitine shuttle. And then a process called beta oxidation occurs. This is the mitochondrial matrix. So that's when you make acetyl-CoA, and then that goes into the Krebs cycle. So, and that's for every 2 carbon unit. So if you have, something called palmitic acid, that's 16 carbons long, that's a fat. You're making net 106 net ATP from that one fat. So you 3 to 4 times more energy than glucose, but this requires oxygen. So if our body's stuck in this metabolic inflexibility we're going to talk about, look at all that energy that we could be burning at rest, but we can't because we're stuck, which we'll talk about. So insulin resistance, insulin is our fat storage hormone. So it's our body saying we've got enough energy, so we need to store it. But in insulin resistance, the body can't use glucose effectively, like we've talked about, which is also, but at the same time telling the body to store fat. So we can't get enough energy. Our body's saying store more fat. So you can see we have all this energy in the body, but we're starved. We're not making energy, even though there's all this energy available in fat. So high insulin promotes fat storage and inhibits fat breakdown. You have lipogenesis, so your glucose and fructose from high fructose corn syrup, sugar, table sugar, is converted to fat in the liver. That's fatty liver. Then you have inhibited lipolysis, so fat cells can't release the stored fat, especially visceral fat. And that's why it's hard to lose that visceral fat. That leads to mitochondrial dysfunction and metabolic inflexibility. And then we start to get ectopic fat found in the liver, muscle, pancreas, starts to accumulate fat. Protein. This is not a preferred form of energy. It can be used, but we really don't want to use it because our body doesn't want to lose muscle. Food or muscle broken down into amino acids, those are converted to glucose, sent into the Krebs cycle. But we don't want to use this form. It's not the first choice because we need muscle. It improves our metabolism. But when we use protein for energy, we break down muscle during fasting, stress, illness, and that's not good. And then it takes longer to rebuild that muscle. Protein is mostly reserved for tissue repair, enzymes, and neurotransmitters. So we want to keep that around. So when the body uses protein for fuel, they're usually fasting. You can have starvation, low carb or keto diets, intense physical stress or trauma, or chronic illnesses can lead to protein being the source. Now we're going to talk about this term called metabolic flexibility. This is the ability to switch between burning glucose and burning fat for fuel. So healthy metabolism, we're like a hybrid car. So we use fat during fasting or just resting, and glucose when we're eating or high intensity exercise. So this is key for energy, weight balance, and long-term health. So metabolic inflexibility is when the body gets stuck in sugar burning mode. We can't access that fat. So can't access stored fat for fuel. Your insulin's usually high. So now that GLUT4 we talked about is down regulated. More reliance on aerobic glycolysis. So number one, you're only burning making less ATP. That fat's going to make what we say 100, 108 ATP. Now we're down to 2. So you can see 2 to 6. So you can see huge difference in in how much energy the cells are making. So this leads to fatigue, brain fog, poor exercise recovery, sugar cravings. So our body's like, we need more energy. Irritability when you're fasting. Post-meal crashes or sleepiness. How many people get that 3 p.m. crash? Like, ugh. And so, that's the blood sugar, that's that metabolic flexibility, inflexibility occurring. Or, you can't, you're just gaining weight despite healthy eating. You're doing the best you can. You're eating a 1,200 calorie diet. You're exercising, maybe over exercising, but that's a different story. And you're just gaining weight or you can't lose weight. It's because metabolically you're stuck. What causes this? Diets high in processed foods or carbs and fats, sedentary lifestyle, insulin resistance or prediabetes, and diabetes as well, mitochondrial dysfunction, just the mitochondria aren't functioning for whatever reason, usually related to inflammation, chronic stress, or toxins. And this is what I see all the time. Insulin resistance, visceral fat, inflammation, stressed out, maybe over-exercising or under-exercising, or in toxins. Let me talk about exercise. So when you're exercising, you're like, okay, I'm going to go to do these high-intensity workouts 3 days a week. I'm going to just get that. Problem with that is if you're already a stressed out person that's inflamed, it's going to increase your cortisol. It's going to increase inflammation, and you're not going to lose weight. And you might actually feel worse. So that's actually not what you want to do with that. There is a device called the Pinoe device, which can help measure your metabolic flexibility and what your max fat burning heart rate is when you exercise. Amazing device. I'm hoping to add that to my clinic soon because I think it's going to be so valuable. So how do you restore the flexibility? You want to improve mitochondrial function. That's making sure you've got enough NAD, B vitamins, coenzyme Q10. You want to try to activate GLUT4 with regular exercise, weight training, cold exposure, cold plunge. Now, it could be just going out in the morning when it's 50 degrees and going outside for a walk. That's cold exposure, not just living in 68 all the time. Try intermittent fasting, doing low carb periods. You can do fasting mimicking diets. You can use supplements like berberine and chromium, alpha lipoic acid. And if there's a lot of inflammation and toxins, we got to decrease the inflammation and toxins. So metabolic flexibility equals resilience. You have better blood sugar control, higher energy and focus. You can burn your fat efficiently. And this is the foundation for weight loss, longevity, and brain health. Mitophagy. I do want to talk about this as well. Mitophagy is the turnover of damaged mitochondria. So, our cells are getting damaged all the time. It's just part of life. Toxins, poor diet, high blood sugar, chronic inflammation, poor sleep, stress, pollution, environmental exposures. All those damage your mitochondria, which leads to a reduced ATP production and a shift to less efficient aerobic glycolysis. So we don't want damaged mitochondria. So mitophagy is the process of removing damaged or dysfunctional mitochondria. This is key for mitochondrial quality control, and it helps prevent buildup of reactive oxygen species and oxidative stress in damaged DNA. So this promotes longevity, energy efficiency, and metabolic health. So when mitophagy is failing, so these damaged mitochondria accumulate, so you have more reactive oxygen species, which are, we talk about in another talk, less ATP, leads to chronic inflammation and aging. Cells shift towards glycolysis for energy. This is called the Warburg effect. And then the reactive oxygen species then damage the mitochondrial DNA, cell membranes, and protein. So this is what we see in things like chronic fatigue syndrome, neurodegenerative disorders like Parkinson's and Alzheimer's, and as well as insulin resistance and metabolic syndrome. So causes of impaired mitophagy could be nutrient excess, chronic insulin signaling, 24/7 food. High mTOR activity suppresses autophagy. So mTOR is going to be when we're in this building mode. So if we're always, again, eating all the time, or if we're bodybuilding and building muscle, no recovery days. Oxidative stress overloads damaged mitophagy machinery, Inflammation disrupts mitochondrial signaling. Aging and NAD decline impair autophagy gene expression. So just the part of aging, and as we age, we make less NAD. Toxins can damage it, mold, heavy metals. There are certain genetic factors, and you can have dysfunctional lysosomes. Think of these as the waste and recycling centers of the cells, prevent mitochondrial clearance. So to enhance mitophagy, we want to activate the AMPK system, or called also the SIRT1 system. That's with fasting, calorie restriction, and cold exposure. We want to reduce mTOR, so that's intermittent fasting, that's time-restricted eating, maximum 12-hour eating window. At times we do want to do lower protein diet. So we don't want to eat high protein 100% of the days. So there might be, a day a week we eat lower protein, or you can do plant-based proteins as well. You can boost NAD with precursors, which are NR and NMN. You can do IV NAD, niacin, or caloric restriction. Quickly with IV NAD. Studies are kind of there's a disconnect, because in the studies doesn't necessarily show that NAD is increased in the cell. But in general, when people do IV NAD, they feel better, they have more energy. So there is this disconnect between what scientifically is going on and what's going on when you get the IV NAD treatment. So it's very interesting. But in general, people feel really good when they do IV NAD. You want to use polyphenols, like resveratrol, quercetin, urolithin A, which is called Mitopure. You can also use fisetin, which is also a senolytic, for those are zombie cells. Peptides, there are peptides that can help. Things like MOTC, SS31, humanin, which helps stimulate mitochondrial cleanup. Exercise, you want to do aerobic and resistance combo. You want to do that level 2 cardio and then do that resistance training. And there are other supplements like melatonin, sulforaphane, berberine, and spermidine as well. So for exercise, I'm going to reiterate, it's zone 2 cardio. That's 60 to 70% of your max heart rate. That's in general. Again, Pinoy can tell you exactly what it is. This enhances mitochondrial biogenesis, increases fat oxidation and GLUT4 expression. High intensity interval training. That's when you're getting these spikes in heart rate when you're exercising. Promotes mitophagy via AMPK. This improves VO2 max and insulin sensitivity. Now the problem with HIIT is what we talked about earlier. Is if you're already high cortisol and high inflammation, HIIT can make it worse. That's where there's amazing technology found by a scientist at NASA called the VASPER device. It uses cooling and compression so you don't get those cortisol spikes and rises in inflammation. It's an amazing device to do HIIT workouts. If there's a place near you, they're amazing. And then resistance training, because you want to increase skeletal mass. Now, I had a talk on back pain. We talked about the M-Sculpt Neo. That is a great way to build muscle. So, there hasn't been a study on this, but if you think mechanical, tough word for me to say, from a mechanism standpoint, the resistance, if you're using M-Sculpt Neo to build muscle, you're increasing muscle mass, so you're going to improve insulin signaling. And actually interesting, the M-Sculpt Neo, when done over the abdomen, can burn 20% visceral fat. Probably one of the easiest ways to burn visceral fat. Why we talk about zone 2? Because we're relying on fat as an energy source. Once we get up above that, you're going to start testing your stressed out mitochondria, build up lactic acid, kind of like what we already talked about. Fasting, you can do prolonged fasting or a fasting mimicking diet quarterly. This helps activate deep autophagy and mitophagy. I really like the fasting mimicking diet because you're still getting in some nutrients instead of just doing a water fast. And it can help lower inflammation and visceral fat. Intermittent fasting, you want to do a 12 to 16 hour fast for maintenance, and that helps support AMPK. So some people are going like, well, why don't I just do a keto diet? Well, with ketogenic diets or keto diets, high fat, low carb, moderate protein, shifts the body into ketosis. So you're using fat and ketones as the breakdown instead of glucose for energy. So it reduces insulin, improves fat oxidation, supports mitochondrial health, and it encourages mitophagy. But why not do it all the time? Because we need balance. It may impair metabolic flexibility. The body can't switch back to glucose use. So you need to be able to have switch back and forth. Our body is a symphony. It's a system of systems. Everything needs to be in balance. So whenever we do something drastic, pushing one way or the other all the time, our body does not like that. Chronic keto can reduce thyroid function, leptin function, neurotransmitters, or sex hormones in some people. High intensity workouts require glucose, so keto may limit explosive performances. And strategic carb reintroduction supports hormone balance and mTOR signaling. So the best use of keto, in my opinion, is using phases or cycles, maybe 4 to 12 weeks max at a time. And that's best for resetting insulin sensitivity, enhancing fat adaptation, and managing brain fog, inflammation, or when weight loss stalls. And then you want to reintroduce whole food carbs 1 to 2 days per week or post-exercise when you're coming out. So there is a role of keto. Personally, I'm not a big fan of keto. People do like it, but when you're using it when you're cycling, I think that's the best way to do it. So in summary, these are the nutrients we need to think about. Magnesium, your Bs, B vitamins, B1, B2, B3, B5, B6. Actually, folic acid in B12 is also needed. Coenzyme Q10, specifically ubiquinol if we're doing a supplement. Alpha lipoic acid, L-carnitine, creatine. Now, creatine, I'm going to stop for a second. Creatine is, in general, safe. It's good for ATP production. People use it for exercise. Some new information is brain health, like doing higher doses, 10 to 20 grams a day for mild cognitive impairment. There's really good information coming out. So, if someone's brain foggy and depressed, tired, throwing in some creatine isn't a bad idea, but higher doses, truthfully. You can do NAD precursors or IV NAD. PQQ, we didn't really talk about. That stimulates mitochondrial biogenesis. D-ribose, that's a sugar backbone for ATP synthesis. So it's good for CHF, fatigue, good for endurance athletes. And then you need iron, copper, sulfur, and zinc. So you need these nutrients for your body to perform at its max. The other part is membrane stability. We want those cell membranes to be stable and not friable. So that's where a newer supplement called Fatty 15 plays a role. I think it's an amazing story in how Fatty 15 was found. Listen to a podcast or read about it. It's fascinating. It has to do with Navy dolphins. I think it's one of the coolest stories I've heard in a long time. But that stabilizes your mitochondrial membrane, supports metabolic signaling. Phosphatidylcholine is another type of supplement you can take, which helps maintain the mitochondrial membrane and support the electron transport chain. Cardiolipin support with DHA, that's a omega-3. Coenzyme Q10 and MitoQ, which is a coenzyme Q10 specifically for the mitochondria. Astaxanthin is something else, and omega-3s. Mitophagy activators, that's the MitoPure again. We talked about urolithin A, berberine. I use that a lot in my insulin resistance patients, fasting mimicking diets, exercise, cold exposure, and PQQ again shows up. And then the peptides we talked about, MOTS-C, SS31, humanin, and there's some other ones that can help support the mitochondria for what more downstream reasons like BPC157, thymosin beta-4, epitalin, 5-amino-1Q, and GHK copper. Now, I know that GHK copper and BPC157 are currently on the no compound list for injectables. So remember, that is injectables only. Sleep's important. You want to get 7 to 9 hours of good quality sleep. Melatonin, is high when we're in the evening time to help us sleep. And it's also a natural mitochondrial antioxidant. So if we're stressed, we're making less melatonin, not sleeping. We're not using our body's ability to use melatonin effectively. Circadian rhythm regulates mitochondrial biogenesis. So if people have really messed up sleep cycles, it causes issues with mitochondria. When we're in deep sleep, that's slow wave sleep that promotes ATP production, synapse repair, and lymphatic toxin clearance. That's like the waste system of our brain. And then when we're in a REM sleep, which is dreaming sleep, that supports neuroplasticity and balances brain energy demands. So it's important to get deep sleep and REM sleep. So, I slept 6 hours. Well, number one, that's not long enough. And, but a lot of people wear wearables. I got my Apple Watch. People have Oura Rings, Fitbits, Garmin's, Whoop bands. I think it is a good idea to understand what's going on as far as your sleep habits and how you're sleeping, as far as deep sleep and REM sleep. And then when we have sleep deprivation, we have less ATP being made, increased reactive oxygen species, and impaired mitochondrial membrane potential. And chronic sleep deprivation leads to insulin resistance, metabolic inflexibility, and impaired mitophagy. Other tools you can do. We talked about IV NAD, methylene blue. Again, avoid with antidepressants. Some people do red light therapy. We didn't delve into that today, but that stimulates complex 4, which boosts ATP production. Sauna, induces heat shock proteins, which stabilizes cells. Cold plunge. We did talk about cold exposure, but cold plunge. You can do pulsed PEMF therapy. That enhances mitochondrial membrane potential and cell voltage, so those cells are signaling better. And then we talked about the Vasper device, which is that exercise with cooling and compression. So, having all these different modalities to help repair the body, increase cellular energy is great that we have all these technologies, and we're understanding how these work more and more every day. A little bit more about Vasper. So this uses compression and cooling and interval training without leading to that increased stress. So you get increased mitochondrial number and density, especially in skeletal muscle. It enhances fat oxidation, increases GLUT4, and you have a better mitochondrial turnover. So, and with that cooling and compression combo, that helps reduce cortisol. So you're not getting the cortisol spike, you're not getting the inflammation. So you're going to do much better with doing HIIT workouts and have a successful, weight loss journey, or getting more energy. Vasper improves lactic clearance as well, and again, talked about reduces cortisol. I really thank you for your time. I know this was a long one. I wanted to get all that information out there for you so you understand what's going on in the body. If you like this video, please subscribe to my channel. If you have any questions or experiences, drop them in the chat. And I hope everyone has a great day.